So what we've talked about in the last unit was multiplying binomials, for example. If I had something on the lines of x minus 5 multiplied by x plus 3, these are what we call the factors of the product that they create. So taking this a little bit aside, pausing that, if I was to say, for example, negative 5 times 3, negative 5 times 3 gives you the product of negative 15. Negative 5 and negative 3 are both considered what we say, vocabulary word, factors of negative 15. So, similarly to numerical expressions such as that, if we look at, going back to the example of the two binomials, this binomial is a factor, this other binomial is a factor of the product that they create. So these are what we call factors of, and then the product is once we multiply it out. So if you used FOIL, for example, you would multiply the first term times the first term, which basically you're distributing the first term to the first, and that gives you x squared. You would then multiply the outer terms, which are the two ones on the outside of both parentheses, and the outer terms multiply to give you positive 3x. Then you would multiply the inner terms of the two parentheses, which we considered negative 5 and x, and the inner terms would multiply to give you negative 5x. And lastly, you would actually multiply the last terms of the parentheses. So we have negative 5 and we have 3, and when you multiply those last terms, you get negative 15. That's where the FOIL comes into play. Now, we're not completely done because it is our responsibility to then simplify this expression. And in order to simplify, we're going to combine like terms, which happen to be the outer and inner terms. So we add those. And so the product, the final product, is x squared minus 2x minus 15. This quadratic trinomial is the product of the factors that are the two parentheses that we started. X minus 5 is one factor and x plus 3 is the other. What we are going to be working on today and in other sections within this unit is going backwards, looking at the product and finding the factors. That's called factoring. So if you were to think about when we used to do numerical factors, if we ask what are the factors of 18, we could say 1 and 18, 2 and 9, 3 and 6. Those are all of the factors of 18. What we're going to be doing is finding factors of algebraic expressions. So let's look, for example, at some of the vocabulary that are going to be very important to understand. So factoring is, for example, when you have a monomial, a one-term expression, it's factored when it's expressed as a product of prime numbers. Prime factorization is something that we have talked about in times past. It's basically breaking down a number, a product, so that you have only prime factors. Greatest common factor is the largest factor that two or more given numbers have in common. For example, numerically, if we were looking at 84, the factors of 84, the prime factors of 84. So factors of 84 are what we did before, where you just list, like, for example, 1 and 84, 2 and 42, and so on. When you're asked for the prime factors, you are asked to break down 84 into only prime numbers. So going back to pre-algebra and times past, you begin with any math fact that gives you 84. And then you continue to break down each of the factors. 7 is prime until they're prime. 12 is not prime, so we break 12 down into 4 times 3. 3 is prime, but 4 is not, So we break 4 down into 2 and 2. So the prime factors of 84 are the numbers that when you break every factor down gives you prime. So 2 times 2 times 3 times 7 is the factors of 84. You can always check your work. 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. You can make another fact. 21, 3 times 7, 21 times 4 gives you 84. So they should make sure that when you factor it, it multiplies out to the original number. So when we're looking to prime factorization of 40, for example, you could start with any math facts you want that give you 40. You don't have to start with 4 and 10 or 2 and 20. I always start with the largest numbers just because I just find it's easier to break them down. So 4 and 10, let's say. 4 is not prime, so I break 4 down into 2 and 2, which are prime. 10 is not prime, so I break them down into 2 and 5, and 2 and 5 are prime. So the prime factors are 2 times 2 times 2, so that's 8, times 5, gives you 40. That is the prime factorization of numerical expressions. Quick refresher, when you're finding the greatest common factor of 2 or more numbers, you're looking to see what all the factors are, and then what you're doing is finding the largest one. There's a couple of ways of doing this. One way is to list all of the factors that give you those numbers. For example, I could say 1 and 24, 2 and 12, 3 and 8, 4 and 6. For 60, I would start with 1 and 60, 2 and 30, 3 and 20, 5 and 12, 6 and 10. Then you look to see which is the largest that they have in common. So I noticed that they have 1, 2, 3 in common, they have 6 in common, 12. 12 is the largest one that they have in common. So the GCF, or the greatest common factor, is 12. The problem with this is that sometimes, as I'm sure you all have experienced, sometimes we forget a math fact. Like, for example, maybe you all didn't realize or remember that 12 times 5 gives you 60. So the other way of doing this may be the way that you want to take the approach of, which would be by listing all of the prime factors, taking any math fact. So let's start with 4 and 6. Let's say 4 times 6. 4 is not prime. 2 times 2. 6 is not prime. That gives us 2 times 3. So the factors of 24 in prime form are 2 times 2 times 2 times 3. Looking at 60, let's say 6 and 10, because that's one that's an easy one to remember. 6 is not prime, so we break it to 2 and 3, which are prime. 10, 2 and 5. So the factors of 60, the prime factors of 60 are, and I always organize them from least to greatest, 2 times 2 times 3 times 5. Now what you do, the approach that we take with prime factors, is you circle all of the factors they have in common. We have a 2, we have another 2, and we have a 3. 2 times 2 times 3 gives you 12. So that means that the greatest common factor is 12. So that's another way of doing it. I prefer using it this way because there's always a time where I overlook a math fact. And in the example that we did before, in how I did this one here, for example, it's very possible that you would overlook one of the math facts, and that would make it a little bit more difficult. So this also will lead to helping with algebraic factors, as you will see in the future in a couple minutes. So let's look at 18 and 27. 18 is 9 times 2. 9 is 3 times 3, so it's really 2 times 3 times 3. 27 is 3 times 9. 9 is not prime, but 9 is 3 times 3, so 27 is 3 times 3 times 3. You could look at it and go, well, 2 times 3 squared, and this one is 3 to the third. Another way of looking at it would be to look at this and go, well, let's see. Greatest common means what is the most that I have in common with both. Let's look at 2's. 18 has a factor of 2. 27 does not. 18 has a factor of 3 squared, so that's 2 sets of 3's. 27 has 3 sets of 3's, so we have 2 of them in common. You could look at it like we have 3 and we have 3, so we really have 3 times 3, which is 9. Look at it also, if you're looking at here, one of the little sayings that I used to say is once you do the prime factors, for greatest common factor, take the least that we have in common. Well, this one has 2 3's, this one has 3 3's, we only have 2 of them in common, so you take the least. This has 1 2, this has none, so you take none. So now, when we're applying it to variable expressions, it works exactly the same way. Looking at 42, I look at the factors of 42. I think of 7 times 6. 7 is prime, 6 is not. 6 gives you 2 times 3. For 18, I think of 3 times 6. 6 is not prime, but 3 is. 6 is really 2 times 3. So it's really 3 times 3 times 2. Check your work always. 2 times 3 is 6. 6 times 7 is 42. 3 times 3 is 9. 9 times 2 is 18. So when we look at these two, we have 1 3 in common, because this one has a 7, this one does not, so we don't have a 7 in common. This has a 2, and so does this. I overlooked that when I just spoke, so we have a 2 in common for sure. And the 42 has a 3, and this one has 2 3's, so we only have 1 3 in common. So what we have in common is a 2 and a 3, which gives you 6. 2 times 3 is 6. So 6 is a factor of 42 and of 18. That's the greatest common factor. Now when we're looking at A's, if this monomial has 3 A's being multiplied and this one has 2 A's, we only have 2 in common because this one only has 2. So the greatest common factor would be 6A squared. If you were to do it the long way with the variables, you could say that 42 has A times A times A, 42A cubed, and 18A squared is 18A times A. So we have 2 A's in common. That's where this comes into play. That's where the saying that I just said a little while ago, for the greatest common factor, take the least that we have in common, comes into play. So let's look at the next one. All right, 16xy squared z squared. 16, think of the factors of 16. Any factors, 2 times 8. 2 is prime, 8 is not. 8, hopefully by now you remember, is 2 times 2 times 2. So 16 is really 8 times 2. Now you could write out the long way, x times y times z times z. And then the next monomial is 72xyz to the third. So 72 is really 8 times 9. 8 is really 2 times itself 3 times, and 9 is really 3 times itself twice. So 2 times 2 times 2 is 8. Times 3 times 3 is 9, so 8 times 9 is 72. Then my variables, x, I have 1, I have 1 y, and I have 3 z's. This is the long way of doing it. What do we have in common? We have a 2, and another 1, and another 1, and that's all that we have numerically in common. Now, variables, I have an x, and so does the bottom one. there's a y that we have in common, and there's 2 z's. This multiplies to 8x, y, z squared. That's the greatest factors that we have in common. Looking at it without having to write it out, you do the numerical part, or you can ask yourself, what is the largest number that goes into 16 and 72? 8 goes into both of these. 9 does not. 10 does not. 12 does not. So 8 goes into both of them. That's where 8 comes into play. Then looking at the variables, we have an x in common, so definitely that's a common factor with x's. This monomial has 2 y's, and this one only has 1, so we have 1 in common. This one has 2 z's, and this one has 3 z's, so we have 2 in common. That's where this comes into play. Okay, so what you're going to be doing is you're going to be doing the independent practice. You're going to write the prime factors of each number. You are going to find the GCF using prime factors and circling what the factors are in common. Here as well. With these that have 3 products or 3 numbers, you're going to have to do 3, they all have to have it in common when you're listing them. And then finding the GCF of all of these factors, sets of monomials. Remember, when you have a negative, such as this one or this one of the factors is -1. One of the factors of the number that is negative, that is. So if this had been negative also, it would also be a common factor. Please make sure that you complete these and upload your final independent practice completed, all completed, to Canvas. Email me if you guys have any questions.